For our first example of Venn diagrams, what we want to do is use the given diagram and identify A union B union C quantity complement, as well as A complement intersect B complement intersect C complement in terms of numbered regions. So, if we're going to start there, in that first part, finding all of those unions and then complemented, we could recognize that all of the areas except for the outer area 8 is going to be included in that union. So, if we want to talk about A union B union C quantity complement, that, actually I don't want to put an equal sign there because it's not exactly equal. I'll just say that is the region 8. My numerals aren't great today, but that's all right. That's what we're getting. And then on the other hand, if we wanted to take the intersection first and talk about the complements of those intersections, actually take the complements first, then take the intersections. Yeah, order of operations are important, even with sets. In that case, what would end up happening when we're taking the intersections is we get everything except for the bubble itself. So A complement would give us 3, 4, 7, and 8. B would give us something like 1, 4, 7, and 8. C would be similar, and what we should see there is that if we took A complement intersect B complement intersect C complement, that actually ends up being the same region, 8 again, which hints for a second time at a very important set of relations that I've talked about earlier, and we're going to be defining more exactingly at the end of this section called De Morgan's laws. But this is one example with very loose regional headings, so let's take one that has a bit more specificity and some more exact numbers to see how these sort of diagrammatic relations work. So for our second example, we're given another three-piece Venn diagram and want to find A union B complement, A complement intersect B complement, and A union B union C. So first thing we want to do here is be careful about what's in each of these sets. That we have A will be 3, 5, 6, 7, 11, and 12. 8's not actually in there. 8's lonely out in C. Or if you prefer, the regions 1, 2, 4, and 5, while B is going to be 1, 2, 5, 7, 9, 10, and 12 for the regions 2, 3, 5, and 6, while C ends up being 5, 6, 7, 8, and 9, which is contained in the regions 4 through 7. So if we want to take A union B using those pieces, we're taking the union of 3, 5, 6, 7, 11, 12, and 1, 2, 5, 7, 9, 10, 12. Which, even though we've got more things involved in our picture, is still the same sort of union that would end up giving us 1, 2, 3, 5, 6, 7, 9, 10, 11, 12. That's the same way, it's just a bit more involved of a picture. Just ignore C. It's just in there. It doesn't matter for that union too much. Then if you want to take the complement of that, well, we're finding the thing that's just in C or just in U, but everything that's in U is in one of those three sets. So that would just be the lonely 8 by itself. Then on the other hand, if we want to take A complement intersect B complement, that means we're looking for basically the things outside of those bubbles, which actually also ends up being 8. So we're getting more hints at the reasonableness of the thing I referred to as De Morgan's laws earlier. Like I said, we'll be seeing that soon. Meanwhile, if we want to take A union B union C, that ends up just being everything. Because if you just look at that diagram, like I said, U is contained entirely in those three bubbles, and we're talking about getting everything that's in the three bubbles. A union in terms of three bubbles just looks a bit more like a Mickey Mouse picture than necessarily like an infinity sign, but it's the same sort of idea. You take anything that's in any of them, so that just ends up being all of the things 1 to 12, our universal set. So, like I said, the operations here, the diagrams here, they're a little bit more complicated. You've got more moving parts, maybe more parentheses to worry about, but really, the math, as it were, is the same. So let's talk about how we can use these more complex ideas, these more careful ideas, to carefully prove things that we got some hints at before.